we will continue our discussion where we left in previous lecture. We were studying differential thermal analysis. We saw that how the endothermic and exothermic reaction produces different types of peak. So we will see some examples also. This is how a normal uh, DTA curve looks like. Okay, so if the peak is downward, it is endothermic. If the peak is upward, it is exothermic. Depending on the shape of peak, we get some idea. Now, if you want to talk about instrumentation of differential thermal analysis, the DTA apparatus consists of following components. First is furnace sample and a reference holder with thermocouple assembly. Now, you will require a furnace. Furnace is a device where uh, something is being heated and it is insulated from outside. So in that furnace, you will require a thermocouple assembly. Thermocouple is used for measuring the temperature. So one thermocouple in sample, one thermocouple in reference. Because we are measuring temperatures of sample and reference and then taking difference, you will require this thermocouple. Then comes sample holder furnace. Obviously, it is for heating the sample. Then furnace temperature controller. It is used for increasing the furnace temperature steadily, okay, with constant rate. Then comes furnace atmospheric pressure control system, or atmospheric pressure, the atmosphere control system, to maintain a suitable atmosphere in the furnace and sample holder. Then comes a low level DC amplifier, direct current amplifier. Now then comes a recorder device. This amplifier is to amplify the signal of the temperature. So let's the first is differential temperature sensor. Now why we require differential temperature sensor? To measure the temperature difference between the sample and reference material. So there will be one thermocouple inserted in reference and one thermocouple in the sample. So both those thermocouples will be attached to this differential temperature sensor and it will measure the temperature difference between these two. The sample and reference holder are kept inside the furnace and the temperature of the furnace and sample holder is controlled by using furnace controller. So this is how the instrument block diagram looks like. We will study one example, DTA of calcium oxalate monohydrate. Okay, let me show you a proper graph of it. Okay, so there are two graphs of the same calcium oxalate monohydrate, one in presence of CO2 and one in presence of air. Please observe it and then we will discuss what it is. Observe the similarities and differences between them. Okay, to begin with, initially both in air and in carbon dioxide media atmosphere, we will observe endothermic change. So that first endothermic change is because of release of water molecule which is associated with the crystals. Okay, then in air you got exothermic and in CO2 you got endothermic. Oh, it is striking difference. Why the atmosphere is making this change? And then again at the end they both have endothermic reaction. Now let us see what it is. The DTA curve for the decomposition of calcium oxalate monohydrate is shown in this particular diagram below. The thermogram shows the decomposition in CO2 atmosphere and in air atmosphere. The thermogram of calcium oxalate monohydrate has three peaks corresponding to the successive elimination of water, carbon monoxide, and then carbon dioxide. These 3 points of weight loss corresponds to the 3 endothermic process. Now, all these 3 endothermic processes are true in CO2. Okay, it is true in CO2. Now, these 3 points of weight loss correspond to the 3 endothermic processes. Curve B represents the DTA diagram for the same compound in air. The second peak in this curve is sharply exothermic but corresponds to the same weight loss as in carbon dioxide atmosphere. This peak represents the exothermic burning of carbon monoxide in air at the same temperature of the furnace. I hope you got the idea why it is exothermic in air. See, carbon monoxide is released, but the moment carbon monoxide is released, it is converted into carbon dioxide by oxidation there. Okay, so because of that, you got exothermic reaction, exothermic peak in air. So, factors affecting DTA curve. Again, there are instrument related factors and there are sample characteristic factors. Okay, that is sample related factors. So first is instrument related is size and shape of the sample and furnace holder. Material from which sample holder is made and its corrosive attack. Then heating rate, the rate at which furnace is being heated. Now, obviously size and shape of the sample and furnace holder, it will uh, it will affect it. Okay, now consider there is a cylindrical sample holder, there is pan like sample holder, and there is a cubical sample holder. One is small, one is large. So depending on not only shape, even by the size, the rate at which the sample is being heated will change. So both size and shape it will matter. Okay, material from which sample holder is made and its corrosive attack. First, the say like heat conducting property, it will be different for copper, it will be different from for stainless steel. But if you will consider copper, it will get corroded faster as compared to stainless steel. So both of these properties will affect the analysis. Heating rate, we have seen that in DTA also. Sorry, the thermogravimetry also. The heating rate logic remains same. Then comes sample characteristic. Now both these points have the same explanation as that was in thermogravimetry. Amount of the sample, whether the sample is smaller or larger, and next is particle size, whether particle size is large or particle size is small. Do we have any Vedant Tiwari in our class?
No, sir.
Do we have any Tiwari in our class?
Kaustubh, sir.
Okay, so this Vedant Tiwari maybe his Kaustubh अभी यहाँ पे present है क्या? नहीं दिख रहा है. Yeah, he's Kaustubh brother. Okay, let him join from his other ID. ठीक है, particle size of the sample. Okay, उसका दोनों का logic same ही है. Coming to the last part of this type of analysis, DTA curves for two substances are not identical. Hence, they serve as fingerprints, identification factor for various substances. It is used to study the characteristic of polymer material. Every polymer will be having different characteristics shown by its exothermic and endothermic peaks. This technique is used for testing the purity of drug sample and also test the quality control of number of substances like cement, soil, glass. If there are more impurities or if there are impurities present in drugs or even cement, soil, glass, the shape of DTA curve will change. It is used for determination of heat of reaction, specific heat and energy changes during melting processes. The trend of ligand stability, that is thermal stability of the ligands, can also be studied using this. The stability of the complexes and the coordination sphere is studied by this method. And that is, this method is also over. Let's start with the third method now, differential scanning calorimetry. Now, the name, okay, it could have been just a differential calorimetry. Why it is scanning? What do you think that scanning signifies? Differential scanning